Welcome to Wisdom Fort Academy.
Hi guys, good morning, good afternoon, good evening from wherever you're watching from. I am Master Steven. In today's edition, we'll be talking about matter in chemistry. Don't forget, in our previous class, we discussed about science and we understand that under the branch of pure science, we have chemistry. That is, chemistry is the branch of pure science that deals with the composition, properties, and uses of matter. We also understand that under the importance of chemistry, chemistry importance span over medicine, over agriculture, over communication, housing, clothing, and manufacturing. Also, we also discuss about some careers in science related to chemistry, like the biochemistry, the pharmacy, the medicine and surgery, and so on and so forth. We should also note that some of the adverse effects of chemistry include corrosion of iron. The corrosion of iron also means rusting, which is the gradual deterioration of iron to iron trioxide, which is permeable to both air and water and cannot prevent the iron from further rusting. That is, corrosion of iron is an adverse effect of chemistry. Other adverse effects of chemistry is pollution, either air pollution, soil pollution, water pollution. They are being released and caused due to chemical reaction. Other adverse effects of chemistry include drug abuse. Drug abuse is the misuse of drug. So before we move into our lesson for today, let's not forget to give us a like, subscribe, and share to support our good work. So today we'll be looking at matter. Matter can be defined as anything that has mass and occupies space. By this definition, everything in the universe can be represented as matter. Let's not forget, we talk about chemistry as the branch of pure science that deals with the composition, properties, and uses of matter. Now, matter is anything that has mass and occupies space. Mass is the quantity of matter or stuff in a body. Matter are made up of subparticles to include atom, molecules, and ion. Now, our next class will be talking about atom, molecules, and ion. So today, let's look at the properties of matter. Matter are made up of two properties. We have the physical properties and chemical properties. Physical properties of matter are those properties that are associated with physical change. Physical properties are those properties that are associated with physical change. While chemical properties of matter are those properties that are associated with chemical change. Physical properties are associated with physical change, while chemical properties are associated with what? Chemical change. Now, what is physical change? Physical change are those changes that are easily reversible and in which no new substances are being formed. While chemical change are those changes that are not easily reversible and in which new substances are being formed. Now, let's look at the examples of physical change. The first example of physical change is change in state of matter. Examples of physical change. The first example of physical change is change in state of matter. Change in state of matter. Let's look at the change in state of matter. From solid to liquid is melting. That is, the process of changing from solid to liquid state is melting. From liquid back to solid is freezing. From liquid to gas, evaporation. Then from gas back to liquid, condensation or vaporization. From solid directly to gas is sublimation. That is, solid that changes directly to gas undergoes sublimation, the sublime. Now, from gas back to solid is known as deposition. Let's look at this together. From solid to liquid. From solid to liquid. First is what we call melting. From liquid to solid, the process is called freezing. From solid to gas, sublimation. From gas back to solid, The process is known as deposition. From liquid to gas. From liquid to gas state is known as evaporation. From gas back to liquid is known as vaporization or condensation. This is the first example of physical change in state of matter. Other examples of physical change include separation of mixture by evaporation, sublimation, distillation, and fractional distillation, and many more separating techniques we'll be looking at in our next class. Also, examples of physical change include magnetization and demagnetization of iron rod. When we add two or more iron rods together and demagnetize them, it is easily reversible and no new substances are being formed. We should note that all these physical changes process, they are easily reversible and no new substances are being formed. Now let's move into chemical change. Let's look at examples of chemical change. The first example of chemical change we should note is addition of metal or limestone in acid. When you add limestone into an acid, for example HCl, a new substance will be formed and it is not easily reversible. Other examples of chemical change include addition of water to quicklime, that is the slaking of the lime. Examples of chemical change include the change in electrochemical series. Other examples include rusting of iron, burning of firewood. These processes are not easily reversible and new substances are being formed. Knowing the difference between the meaning of physical change and chemical change, let's really look at the differences between physical change and chemical change. The first difference between physical change and chemical change, let's know that in physical change are easily reversible, while chemical change are not easily reversible. In physical change, no new substances are being formed, while in chemical change, new substances are being formed. In physical change, there is no change in the mass of the substance that involved in such change, while in chemical change, there is entire change in the mass of the substance that participates in such change. Last one should note is that in physical change does not require great amount of heat except the latent heat of vaporization for change in state of matter, while chemical change requires great amount of heat. Also, matter are classified into three. Matter are classified into elements, compound, and mixture. What are elements? Elements are substances that cannot be split into simpler units by an ordinary chemical process. Scientists have discovered over hundreds of elements, including the common one like the oxygen, the hydrogen, the carbon, and the unfamiliar ones like the actinium, the xenium, the rubidium that are found beneath the earth crust. There are 109 known elements. 90 of them occur naturally, while the rest are prepared artificially in the laboratory. We use symbols to represent elements. For instance, oxygen will be represented with the symbol O for oxygen, while hydrogen is represented with the symbol H for hydrogen. Before we continue, let's briefly look into the first 20 elements for summary. Now next class we'll look at simpler way to understand the first 20 elements, their atomic number and their symbol. Now the first 20 elements commonly for high school students or secondary school students include the hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. There are 6 types of elements in each phase. They include the reactive metal, the transition metal, the lactinide and actinide, non-metal, pure metal, and the noble gas. These elements are further grouped into the metal, semi-metal or metalloid, and non-metal. We have the metal, semi-metal or metalloid, and non-metal. What are metals? Metals are those elements that ionize by losing electron. Metals are those elements that Ionize. Let's use metal. Metal are those elements that ionize by losing electron, that is by electron loss. Metal are mostly electropositive, and familiar examples include sodium, magnesium, potassium, calcium.